Hello, welcome to my talk. The title is Self-Hosted LLMs Across All Your Devices and GPUs. So in this talk, we're going to talk about self-hosted LLMs. And we're going to primarily use three open source projects. One is called the llamaedge, and this is the CNCF project that I founded. And it is a WebAssembly runtime that see great adoption in AI and the large language model space. And then the second project is called llamaedge. llamaedge is an open source project that built upon llamaedge. So it provides tools and SDKs and programming primaries for building large language model applications, especially around the Llama 2 model, on the llamaedge runtime itself. So when it's a runtime, you can see this as an operating system. And then llamaedge is infrastructure that specifically for building LLM applications on top of llamaedge. And then the third project is GaiaNet. GaiaNet further builds upon llamaedge to provide what we call a RAG application server, meaning that we supplement the large language model with real-world knowledge base, either from public data, from public knowledge, or from our proprietary knowledge. And that just makes LLM models and the applications that are associated with it much more useful. So it's designed for use with AI agent applications and such. So we'll start our talk with a demo of how easy it is to run a chatbot using the open source LLM on your own device using llamaedge. In this demo, I'll show you the easiest way to run a large language model on your own computer. First, go to the llamaedge/llamaedge repository on GitHub. It is an entirely open source project. So in the README file, while you are here, just give it a start. And in the README file, you will see a quick start guide, and there's just one line of command. You copy this, and then go to your Mac or Linux computer, or even Windows with WSL to run this command. What it does is that it can install a large language model runtime called the llamaedge plugins that are required to run the large language model. And it goes fast here, but as you can see, it downloads a large language model called Gamma 2B, which is one of the Google's large language models. And you can actually run any large language model that you find on Hugging Face. There's over 5,000 of those. And just go back to the README and look for the parameters that you can pass to the script where you can specify the model, which even as a Hugging Face URL. And once the model is started, it says the application starts a local web server on your own device. And it's started on port 8080. So what you can do is that you can go to that server, and it would load a URL. And the URL said llamaedge chat. Now you can start to chat with it. Say, where is the capital of Japan? The first time it is a little slow because it needs to load the model into memory. But it's fast enough. The capital of Japan is Tokyo, and now you can ask, what about the USA? And it clearly shows that the model understands the conversation, right? Because the second question I did not tell to find the capital of the USA. I said, what about the USA? It knows about Washington, D.C. because it knows about the previous conversation. If we go back to the log, we can see that it's generating, with the Gamma 2B, it was generating over 60 tokens per second. That's a lot faster than a human can speak. A human typically speaks, when I'm speaking now, it's about 3 to 5 tokens per second, right? So it's 10 times faster than a human can speak. Now I can ask a longer question. Plan me a one-day trip there, meaning one-day trip to Japan. Okay, so it's I should have said Washington D.C., but that's close enough. That's it gave me 2 days as well. But this is one of because this is a very small. It's a 2B model. If you change it to a 7B model or even larger model, you're gonna see it respond a lot better. But even so, it is still pretty good. It gave me an itinerary of it's on day 4 now. It's maybe a week in Japan, right? So that's it. That's how you run a large language model on your own computer. I'm running it on the Mac, and I'm recording this video while running it. And so it's even then I can get 60 tokens per second. So it is one of the easiest way and fastest way for you to run. Again, it's gave me the whole week. So again, the URL is github/llamaedge/llamaedge. And there's just one line of command. And once you get to start running, you can run other models by reading the rest of the README, and you can use that as an API server, and you can do a lot of things with it. Okay, now you have seen the demo. So what's it all for? We have seen that you can run a large language model application. You can chat with it on your own device. But what's it for? Aren't most people just use OpenAI for this purpose? And OpenAI also provides SDK API, right? So you can build applications around it as well. So why is there need to run those open source large language models on your own device? Well, so there are a couple of reasons. The first, biggest reason really, is that OpenAI or any other large language model providers basically takes a one-size-fits-all approach. So basically, they're using the largest model for the smallest tasks. So even if you ask for something that can be easily handled by a smaller model, it will still use the largest model, which generates a lot of waste. It was very expensive, and also makes the models very difficult to fine-tune because it's much harder to fine-tune a large model than a smaller model, right? And because it's running on other people's server, because the model is too big to run your own server, so it's lack of privacy and control. And perhaps more interesting, and I think people are noticing this more and more, is censorship and bias, because those companies like OpenAI or Microsoft all have their own political stand and agendas. So you would find a lot of questions that those models refuse to answer. So I would say there's very compelling needs for enterprises or users to run their own models, preferably on their own devices or in the cloud. Right? So then that raises the second question. The llamaedge server probably is not the first or the only open source software that can run large language models. So for instance, llama.cpp can run it, or Llama can run it, AI Studio can run it. So why is it that we choose the llamaedge or the wasm-edge stack to run our API server around those models, as we have shown in the previous example, right? So first is I think there are several features that distinguish llamaedge from other products or other open source projects in the space. So the first is to support a wide variety of models. So the llamaedge application server supports over 6,000 large language models, including all the ones that you have heard of. And there's not just the base models and chat models, but also embedding models, which are essential and very important for running sophisticated applications, as we are seeing, like RAG applications. It even supports larger models like X.AI's Grok model, which is, I think, 314 billion parameters, and it requires top of the line, say, a Mac Studio or two H100 chips, graphic cards to run those models, but they can run using llamaedge. And on the other hand, so that's on one hand, it's that support a wide variety of models, but on the other hand, it's also support a wide range of devices, because once we start to run on our own devices in our own cloud, we have to deal with many different types of different devices, different GPUs, different CPUs, and different graphic cards, different accelerators, and all that. So the architecture of llamaedge, because it's based on the wasm-edge runtime, which we will get into in a minute, it provides an abstraction layer that abstracts the application from the underlying runtime and the hardware. So that allows the same application to run on a wide range of devices and drivers, ranging from NVIDIA to AMD to ARM devices to Intel and AMD's CPU and GPU devices, the Apple devices, and all of those. So in a minute, so I just showed you it runs on a Mac device, and I'm going to show you how it runs on an NVIDIA device. And we also have tutorials on how to run, say, on Raspberry Pi or the Jetson devices. So all those, I would say, devices more commonly found in the edge cloud, right? So The llamaedge API server also provides enough flexibility to run multiple models in the same server. So meaning that I can run a chat model to chat with people and run the embedding model in the same server so that the user can upload or and process their external knowledge base with the same application server. It can also do things like function calling by forcing the output to be JSON. That's something that needs coordination between both the model itself, the prompting, and the model runtime. Meaning that the model runtime would have to force the output to meet certain grammar check, to pass certain grammar check. For instance, it has to be valid JSON, right? And as you can see, it's very easy to install and run. It's just one line of command, and I highly recommend you to try it out. And it's also very, very lightweight because it's the entire runtime, llamaedge plus the application itself is less than, say, 30 megabytes. That compared to, say, the PyTorch Docker image we talked. The PyTorch Docker image is 4 gigabytes by itself. So that's why you even when running a large language model and put the API server in front of it, put a chatbot in front of it, we use llamaedge, right? But all those benefits actually come from one most important attributes of the llamaedge runtime, which is it is not really designed to be a standalone server to run large language model. It is actually a developer platform. You can write your own code to extend it and to customize and build your own applications on top of it, right? So if you think about how large language model applications are built today, it is typically you have an application server. That provides API. It's either OpenAI or some other SaaS provider, or you can use your own. Like using llamaedge, right? That's you provide OpenAI compatible API server, and then you build your application that consumes this API in a relatively heavyweight stack, like in Python or LangChain or Llama Index. There are lots of tools out there to do that, and you would also have a UI, have a web server, have all those components either contained in a Docker file, something like that, and have them all tied together and build an entire application like that. But while this is provide flexibility and easy, allows developers to experiment with different parts of the stack, it is also making it really difficult to deploy those applications because they have too much dependencies. They are huge because of the Python dependency, and they are often very slow. So llamaedge is a Rust-based SDK, essentially. It allows you to build a single portable and deployable app. So basically you can write all your logic into one single application. There's no need to write part of the logic in C++, part of that in Python, and then use the HTTP API to connect them together. You don't need to do any of those. So it improves efficiency, make it a lot easier to deploy, and it simplifies the workflow. And again, there's no Python dependency. A lot of people, if you haven't really worked in the large language model space in the past, that's Python dependency is actually a nightmare, even for very experienced people in this field, right? And you can use Rust, or you can use JavaScript. That allows us to build applications that are similar to, say, the latest advance in OpenAI. So if you look at OpenAI, they have Assistance API, right? They have a stateful API that build a lot of functionality into the API server itself. So the llamaedge platform allows you to develop your own API server and to serve whatever the front end that you want to do, right? So that gives you a lot of flexibilities in terms of building advanced applications. So if you pay close attention, there's a word that I put in bold here, that is single, portable, and deployable application. So meaning that's, you are talking about a developer platform that is based on Rust, that has no Python dependency. One of the biggest issues people are going to ask is that, how about cross-platform compatibility? Because for native application, for highly efficient native applications like that, if you write it on one platform, it's likely you are not going to be able to deploy it on a different platform. That sort of makes it really difficult for developers, because I have a Mac or Windows, but my application that compiled and tested there, is that really true that I can't deploy it on a media device in the cloud? So in the next demo, I'm going to show you how the llamaedge and the llamaedge stack address this problem, that we allow you to build truly portable large language model applications. So here's a demo. In this demo, I'll show you a key benefit of using WebAssembly or WASM to run LLM applications. Portability. The WebAssembly application is a binary application that is directly portable across different operating systems, hardwares, and drivers. So on this screen, I have opened my a terminal to my remote machine on Microsoft Azure. So that machine runs Linux, has an NVIDIA T4 card, and runs have the CUDA 12 driver installed on it. If I see what's in here, you can see I have downloaded the large language model, the Gamma 2B model in GGUF format, and then a bunch of HTML and JavaScript files in the chatbot UI. I have also installed the llamaedge runtime here. So if I say llamaedge, it's llamaedge 13.5. So now we have the large language model, and we have the runtime for the large language model. We are still missing the application. The application is something that takes the user input, runs the large language model, prompting the large language model, runs the large language model, generate a response, and then send it back to the user. So you can call it a chatbot application. It could be a web application. It could be a Discord, or it could be agent application that connects to other applications that takes the large language model output to do things, right? So the application is a key part that as developers that you would write, right? So in the past, you wouldn't expect this application to be portable, because when you develop this application, you are probably on the Mac or Windows machine, and you compare it to, say, Apple Silicon and use the Metal framework. You have all this built in. And you wouldn't think that by just copying this binary application to an NVIDIA machine, it would just run there, right? And of course, there are ways to make it easier. So for instance, if you use Python, Python has a lot of abstractions that allows you to write at a fairly high level, so that you can write a Python script on Mac and then try to run this same script on the Linux machine. However, as you would imagine, Python, in order to achieve that, Python have a huge amount of dependencies. Like if you go to the PyTorch official Docker image, it is 4 gigabytes right there, right? So the PyTorch Docker image itself is 4 gigabytes, and it's platform dependent. So you have to install the right Python version, and within Python, you also have, oftentimes you need to specify what is the underlying architecture. So it is huge dependency, and it's not really that portable. For any other languages like Rust or Go, or if you write your application in any of those other languages, you would not imagine that it would be portable. That's because the underlying GPU and CPU architectures are entirely different. And what WASM does is that it provides abstraction for those applications so that it can run smoothly across all different platforms. In order to demonstrate that, I switch to a window. This is on my local machine, which is a MacBook. And what I have already downloaded, one of the API server applications from the llamaedge project, which is a Rust application. And I compiled it on my Mac, and I tested it on my Mac, right? So now what I'm going to do is I'm going to just SCP this entire file to the remote Azure machine. So as you can see, the entire file is only 9 megabytes. And we didn't package it in any way. We didn't have a Docker image around, wrapped around it. We just SCP'd the whole thing to another machine, and with entirely different architecture in both hardware and software, and expect to run there. Can we run there? So let's see. So we use the llamaedge runtime to run it. So the llamaedge runtime starts instantly. It's because it's an application, so it loads the large language model, and then it starts an API server. The web server is actually accessible through port 8080. So if you have this machine, the port open to public, you would be able to load up browser and go to port 8080 and would be able to see it. But for now, we want just to stay on this machine because we have it under a firewall. What we're going to try is that we're going to do an API request, because this API server also takes OpenAI style API requests that allows us to integrate with all the OpenAI ecosystem tools. So here's how the requests look like. So as you can see, we request at localhost, and then we send a message with a role of user and say, where's Paris? We ask the model, where's Paris, right? If I do this, it does the inference, its result come back before I can finish speaking, right? So the result is, the role of the result is system, and the content is Paris is located in the heart of France, blah, blah, blah. So now we have achieved something I think very interesting, is that we compiled a Rust application on the Mac, and fully taking advantage of the Mac GPU and the Metal framework. And then we just copied this Wasm application into a remote Linux machine running on NVIDIA. And we can see this application, which the role of the application is start server and interact with the underlying large language model, runs just perfectly on the new hardware, fully utilizing the NVIDIA GPU capabilities to accelerate. Without the GPU capabilities, you would not be able to have nearly 100 tokens per second speed on this Linux machine. If you're just using the CPU, you'll be more like 1 tokens per second. It would be 2 orders of magnitude difference. So that's it. We have shown that the Wasm application is truly portable. All right. To recap the demo, there's for the longest time we have platform engineering or DevOps, that combines the role of developer and ops. But with the new hardware, with more and more different devices and different drivers, all that stuff that's coming along for AI applications, that I think it's time to separate the dev and ops role all over again, right? So the way it works is that WebAssembly is a virtual machine format. You can think of it like a Java bytecode, right? So it provides abstraction over the real hardware. And for developers, you just need to write to the WebAssembly interface. In our case, you write to the llamaedge SDK interface. And it tells the SDK to say, load a model and do the inference. And the developer only need to write application in this way. So if once the application is compiled to Wasm, the developer's job is done. He or she can ship the application anywhere that they want, and let the runtime takes over the rest. So it's the ops people that needs to install the correct runtime and the driver for each device. So for instance, on the Mac, we want to install the Mac version of llamaedge. It's sort of like Java. On the Mac, you need to install the Mac version of Java, right? The JVM, right? So it's the same thing here. So you want to install the Mac version of the llamaedge runtime. If you have an NVIDIA device, you need to, on Ubuntu with CUDA 12, you need to install the appropriate llamaedge runtime in there as well. So for the ops guys, they can, once they take care of that, they would be able to just run that Wasm application without any modification, because the llamaedge runtime has a standard API that is defined in the llamaedge SDK, right? So once it sees those instructions to say load a model and send some text to the model for inference, and it sees those instructions, the bytecode, it will automatically run those code and it would translate those code into that's instructions that are appropriate for the underlying accelerator and the drivers. So it allows developers to write truly portable applications that can be deployed anywhere and can be managed by tools like Kubernetes, and let ops people worry about installing the right driver and installing the right llamaedge runtime on every single node or every single edge devices that you have in your cluster. So that leads us to our last demo, because we have talked about llamaedge being a developer platform. And one of the most popular applications people do with Python, at least today, is what they call a RAG application, meaning that you use a standard large language model, a fine-tuned large language model, but you feed it with your proprietary knowledge base. The knowledge base was divided. It's typically a text, a PDF or image or a text file, and it was divided into segments, and each segment was turned into a vector and stored in a vector database. And when the user asks a new question from the API, the application would take that question, turn that into vector as well, and then perform a vector search in the database to find out which texts in the knowledge base are most related to the question. And then it would add the context that retracted from the knowledge base and the new question into the prompt and asks the large language model to give an answer, right? As you can see, this is a fairly complex process, and it involves not just the large language model, not just the runtime, but also things like the vector database, the embedding model, and all that, things that you have to tie together. And as we talked about, previously in this talk, is that things like that was traditionally done by, say, fairly complicated Python programs that does the orchestration, the queries, the turning into vectors, the embeddings, and all that stuff. And then you attach another UI in front of it. So it's a fairly involved and a complicated process. But with llamaedge, we will be able to build a single application that can talk to the vector database, call the embeddings when it's needed, and perform the vector search, and then at the end prompts a large language model to get an answer. Right. So this project we call it an integrated assistant API server, which because it looks a lot like OpenAI's assistant API, and we call this project the GaiaNet. And here's a demo for that. Hi, in this demo, I'll show you the easiest way to run a RAG or RAG API server for a large language model. So if you are familiar with RAG, it is a way to add knowledge. It could be additional public knowledge or proprietary knowledge that you don't want other people to see to an existing large language model, so that the large language model can answer questions and chat with people based on the additional context that you provide to it, right? So in order to do that, a typical RAG setup requires a fairly complex setup that requires, say, additional vector database, install additional vector database, UI, how to upload the knowledge, and the tools like LangChain to orchestrate how to manage, retrieve data from the vector database, and how to prompt the application. So in our approach, that we want to introduce a project called GaiaNet, and the GaiaNet is an application that is built on llamaedge. So and also using the llamaedge framework. So what it does is that it allows applications you can write simple RAG applications using Rust, and then compile into a single WASM binary with zero Python dependency, and run it very efficiently at the server. So let's see how it works. If you go to the GaiaNet GitHub repository, by the way, if you are here, just give us a star, find the, and here is a quick started guide. And this is called Gaia node, and there's a one line of command which you can use to install Gaia. Which let's do that and explain what it does. So this is on my local Mac machine, and if I say install, what it does is that it installs the llamaedge runtime, and which is required to run a large language model. It installs a quadrant vector database, which is required. And it's download a chat model, which it has already downloaded. We call it the Llama. It's a standard Llama 27B chat model, and it's download the embedding model, which used to process the vector. And but here, what's really interesting, you can ignore the error here. What's really interesting is that it's also downloads a knowledge collection, which is a knowledge base we vectorized into the quadrant format. You can read in the documentation how we do that, and we have a separate Rust application that that helps you to do that. And then it's it installs that snapshot into the quadrant database. So if you go so what it does is that it creates a GaiaNet directory in your home directory and put everything in there, and including this WASM file that starts up the RAG application server. And here, if you look at the config.json, you will be able to see the chat model that's being used, the parameters for the chat model, and the snapshot is knowledge base the vectorized knowledge base, and the prompt. And you can modify any of the things that you want, use a different model, use a different knowledge base, and rerun and install. Right. So once you have everything installed, that you would be able to say run the start script. What it does is that it's going to start the vector database, like we said, and it's going to start the llamaedge application server, and it's going to start a domain server, which give it the public access for domain for the server, right? So what we're going to do is that we're going to open while this is runs on our local machine, I can use localhost, but I can, because it gives me a publicly accessible domain. So what I'm going to do is that I'm going to go to load this public accessible domain. So it gives me how to access the API, but what I would do is that I would just chat with the node. While it's loading, I would come back here and tell you and open up the log here. So this is the llamaedge startup log, which logs all the interactions with the large language model, right? So now it's the UI has come up. I want to demonstrate to you that it does use the knowledge base to chat with us. So if I say where's Paris, because the knowledge base I'm using right now by default is a guide the knowledge come from a Paris guidebook. So I vectorized that Paris guidebook and put that into the vector database, so that it's the large language model can generate answers for me. So it says, thank you for the question. Based on the context, Paris is located as north central part of France, blah, 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 blah. How do we know that this is actually using our context? How does we know that our RAG application server works? We go back to the log and we can see the actual prompt. So you can see this is the actual prompt the application server sends to the database. So you are helpful assistant, and then here's the context. If you don't know, if the answer is not in the context, you don't answer it. So those 3 paragraphs of context come from our vector database. That's come from the Paris guidebook. It's about general information about Paris. And then we ask a question, where's Paris, right? So it's answers based on that context, right? So you can ask follow-up questions, of course. You can plan a one-day trip or whatever. And you can also use it as OpenAI API server. As you can imagine, you can have your knowledge base about a code repository and then use a fine-tuned model that generates code or JSON and have this packaged together as an API server that connect to a chatbot or something like that. That allows you to build an entirely portable application that can run across many different GPU architectures and drivers without any need for large dependencies like Python. All right, so that brings an end to our talk. I think we're gonna have 30 minutes, and we have done 3 different demos, and from the easy to the most sophisticated. And I hope you would have time to at least install llamaedge on your own computer and install large language model so you can play with it. And if you find it interesting, you could install a GaiaNet node and build your own knowledge base and have the large language model on your own device answer questions in the way that you want, right? So yeah, that's there are a lot more that we can get into. So for instance, what's the Rust application look like, how the SDK look like, and things like that. But I don't think we have time for that at this moment. And if you are interested, we have those 3 open source GitHub repositories that you can go to, and please feel free to raise an issue and find us there and chat with us. All right, thank you so much. Bye bye.